So here with question 2, we have a continuous random variable and we've been given the cumulative distribution function. Be really careful to look out for that. So the clues are in the question and the fact we have capital F of x. We've been asked to find the probability that x is greater than 4. The cumulative tables will find the probability that x is less than or equal to any value you substitute in. So straight away, I know to make use of the tables, I'm going to need to do a 1 minus. So 1 minus x is less than or equal to 4. Writing the less than or equal to is a little bit redundant since we are working with a continuous distribution. Okay, so this just now needs to be substituted into the continuous random variable that we have. There's only one viable function to put this into. So we're looking for 1 minus a fifth, or 4 minus 1. Quite a straightforward calculation this time. 1 minus 3/5. Final answer, 2/5. Okay, a nice straightforward opener on this question. Okay, so here in part B, we've been asked to write down the value that x does not equal 4. All right, so a question that we may not have seen the likes of, but a little bit of thinking should get us there. The probability that x does not equal 4 should be 1 minus the probability that x does equal 4. Since not equaling 4 and equaling 4 should be exhaustive, the two of them should add up to 1. The probability either equals 4 or it doesn't equal 4. So 1 minus probability that x equals 4 should get us our answer. And once again, we're working with a continuous distribution. So finding the probability that this is exactly 4 is such a small probability that it's extremely negligible, and we just refer to it as having a probability of 0. So it was 1 minus 0, which is 1. So these small mark questions do accumulate. Let's make sure we think them through correctly. On to part C. Here we were asked to find the probability density function of x, specifying for all values of x. So starting with your cumulative distribution function, to generate the probability density function, the PDF, we're going to want to differentiate. So differentiating this expression, so d dx of, I'm going to expand these brackets quickly, is going to equal simply 1/5. The constant negative 1/5 is going to disappear. So to specify the entirety of the probability density function, I'll make sure it takes its regular form. So the f of x, the only function to describe is the 1/5, and that is valid from 1 up into 6 inclusive, and it will be 0 otherwise. Okay, something to immediately take into account. This, if I was to sketch it, is just going to be a horizontal line in between 1 and 6. Let's quickly get that sketch, see if you can recognize what I recognized. So 1 and 6. The PDF is 1/5. From here, we can see that actually we had a cumulative uniform distribution. No words were mentioned, there was no clues in the question, but recognizing the type of PDF that we'd produced let us know that actually we now have a uniform distribution. Let's see if that comes into play in the rest of the question. Okay, simply asked to find the expectation of x on a uniform distribution. We know it's going to be the middle value, right in the middle of 1 and 6. We're going to find 3.5, but more formally, the expectation of x is going to equal a plus b, the smaller limit and the upper limit, divided by 2. That's 1 plus 6. Divided by 2, and that once again leads to 3.5. Decimal point disappeared. 3.5. Okay, the variance of x. The variance of x, once again, there's a formula for this when we're working with continuous uniform distributions. The variance of x is b minus a, so that's the width of the rectangle, the width of the distribution, all divided by 12. Substituting in the values that we're aware of, that should be 6 minus 1 all squared and divided by 12. 25 over 12. And I'm happy to leave it like that in fraction form. It will probably be easier to manipulate later on, and I don't need to do any rounding, so I can maintain accuracy. Okay, so hence or otherwise, find the expectation of 3x squared plus 1. Straight away I'm itching to do some expectation algebra. So starting with 3x squared plus 1, I know that that should equal 3 times the expectation of x squared plus 1. Okay, all I need to do now is find the expectation of x squared. In the previous two parts of the question, I found the expectation of x and I found the variance of x. That straight away triggered a very useful formula. Variance of x equals the expectation of x squared minus the expectation of x squared. Okay, so rearranging this, I should be able to find the expectation of x squared. Let's go ahead and rearrange. And substitute. Now just into the calculator and we should get, okay, so that's my expectation of x squared. Going back to what the question had asked, I need to find a result for this expression, which would be 3 times the 43 over 3 plus 1, resulting in an answer of 44. Okay, so the answer to the question, 44. And that should be worth all the marks.